Hello, today we have an exciting topic. Today we're talking about the Malonic ester synthesis. This is a pretty exciting reaction where we can start applying all the concepts learned in terms of enolates and applying them to making new types of molecules with new functional groups here. So what we're going to do is we're going to make an enolate. Instead of having an enolate attack a carbonyl, let's have it attack an alkyl halide, right? Alkyl halides are great electrophiles. So let's try to attack those and add new carbon sources onto our enolates. So with our Malonic ester synthesis, we're going to start with an ester. And we're starting with this ester that has these two ester groups here. This is going to be our diethyl malonate. Okay, diethyl malonate here. And what we're going to do with this is we're going to do 3 steps. First step is going to be adding our base, right? We're going to have base in there because we want to deprotonate this carbon, alpha carbon here, to make our enolate, right? Once we make this enolate, our next step is then going to be addition of our alkyl halide. Now, right now we'll call it R1, and we'll put a bromine there. That's fine. So we're going to add that alkyl halide group here, this alkyl group here, right? And then our step 3 is going to be H3O plus and heat, right? We're adding our H3O plus there because we take esters, react them with H3O plus, they're going to go to carboxylic acids, okay? But the interesting part is when we add heat in there, we're actually going to have something called a decarboxylation happen, where we're actually going to lose one of these groups here, okay? The end result is we're going to generate a carboxylic acid that's going to have our R1 group attached to it, right? So it's pretty exciting. We can take an alkyl halide and basically turn alkyl halide into a carboxylic acid, right? It's a pretty nice reaction. So in this video here, we'll just go through the steps of it and kind of talk a little about each step. And then in the following video, we'll actually do an example, a real life example of this. So let's go through the steps of this process. So our first one is making our enolate. We've made quite a few enolates before, right? Nothing too exciting here. Now remember, we've talked about this alpha carbon that's attached to 2 carbonyls, right? This one is very acidic. pK of that is what? Remember what pK was? It's around 9, right? pK is around 9. And so what we're going to do here is we're going to deprotonate that with our base. Remember we talked about this before when we did our Claisen reactions. We were concerned about deprotonating this one because it's fairly acidic, right, under basic conditions. So this case here, we want to deprotonate it. All right, so we went ahead and we deprotonated this alpha carbon to make our enolate here. We have this negative charge on this carbon here, right? Now we're going to take this group, and what are we going to do next? Our step 2 is we react it with our alkyl halide. In this example here, I just wrote R as our alkyl group. Already we know this one's a fairly strong nucleophile. So when we add our halide in here, we generally want to use primary alkyl halides. Those work the best. So they're going to be the fastest, right? We already can kind of guess what type of mechanism this is going to go by. And when we do this reaction here, we're doing this reaction here is going to be an SN2 type reaction, right? So those primary alkyl halides are going to work the best, right? Those small ones, primary ones, are going to work the best. Okay, so it's SN2 like. SN2 reaction. So we're going to use primary alkyl halides. Okay, so we're always going to want to use those primary alkyl halides work the best, right? Primary alkyl halides, those are the ones we want, because we're going to attack this group here, and we'll kick this group off, right? So generally when we do these type of reactions with our enolates, we're going to want to attack those primary alkyl halides, right? Those work the best. That's what we're looking for. Okay, so we're going to do that, kick off that halide group. Okay, we've added our R1 group in there, right? We've added our alkyl group in there, okay? So we've done the first 2 steps. So we made our enolate then attacked our alkyl halide. Generally, this alkyl halide is going to be what? They're going to be our primary alkyl halides. Now, our third step is interesting, two parts of this. Let's talk about the first part. We're going to take this and we're going to react with H3O+. And again, we're not going to go through the mechanism of this. We've seen this before already in previous videos. You can go back over and look at those ones where we react esters with a acid with water, right? We're going to convert that into a carboxylic acid. And again, it's a nice mechanism. Definitely should review it if you need more help with that mechanism, because it's a good mechanism to do, right? But we've gone through it quite a bit. We're at this step here, though, where we made a dicarboxylic acid, right? This is kind of special because we have two carboxylic acids, attached to the same carbon here, right? This is kind of interesting here. Now, under heat, what's going to happen is we're going to do something interesting here. So let's go ahead and we'll erase the board and let's work our way up here so we have a little more room to work with. So we're going to have this screw here, and I'll rewrite this for you. Yeah, like that. Okay. And with heat, what's going to happen is we're actually going to decarboxylate this, right? And it goes through this kind of cyclic mechanism. Again, we're not going to worry too much about the mechanism, just showing it for fun, is that we're having something like this happen, right? Okay, we get this type of cyclic mechanism here. And what's happening here basically is we're actually doing a decarboxylation. So it's a decarboxylation. Okay. The important thing is we know we're going to do a decarboxylation. So we're actually going to lose this piece here. And what happens is when we do this, oops, I forgot my R group down here, R1, is we get something like this, right? And we've seen this similar before, right? If I didn't have this OH group in here, I'd say, oh yeah, that's an enol, right? We've seen those before, right? So it's an enol-like molecule there. And what happens is, this is not very stable in this form here. So it's going to tautomerize. It's going to tautomerize back into having a carbonyl here. Because having that carbon double bond to the oxygen is more stable than having this carbon double bond here, okay? That carbonyl bonds are more stable, okay? And so what happens is that this is going to rearrange, tautomerize. It's going to form our carboxylic acid, okay? And so that's what we end up with, is our carboxylic acid at the end. So we end up with our carboxylic acid. Not only that, but we ended up with the alkyl halide, that alkyl group of the alkyl halide is attached there as well, right? So we add this whole group on there, okay? So with our malonic ester synthesis, we're able to take our diethyl malonate. Again, we need those two ester groups right there. Make the enolate. Enolate then attacks alkyl halide, right? And then once we made the alkyl halide, under H3O plus conditions, right? H3O plus, we're able to convert the esters to carboxylic acids. And that mechanism we've gone over before. And then with heat, again, this all happens all together. We're at H3O plus heat. This all happens together where we're able to then make the carboxylic acids, make this dicarboxylic acid special, it's attached to the same carbon here. And then they're able to decarboxylate. We lose this group here, decarboxylate. We're going to lose CO2, right? This loses CO2. And we end up with just our carboxylic acid group here, okay? So it's a great way of taking an alkyl group and then converting it into a carboxylic acid, right? It's a great way of doing that, adding more carbons and things, right? And also getting this carboxylic acid function group, which is great. We can do a lot of chemistry with it, okay? So this is our malonic ester synthesis. So in this video here, we just kind of walk through the steps, so kind of what's going on, talked about it a little bit. And then in the next video, we'll show an example of doing the malonic ester synthesis with actual alkyl halide and things like that, right? And then go through the mechanism again. Again, this mechanism, I'm not real too worried about this one in terms of focusing too much on this one. We just know that we add heat to it when it's a dicarboxylic acid like this. We're going to decarboxylate, and we're going to end up with the carboxylic acid. So in future videos, we're just going to say that H3O plus heat will give us the carboxylic acid, okay? It gives the carboxylic acid. All right, so malonic ester synthesis.